Hey guys, welcome back to another Math Moguls video. Today we're going to be doing some multivariable calculus, especially partial derivatives and high order partial derivatives. So here we have the problem f of xy, which means that we're talking about three-dimensional calculus using the x, y, and z plane, equals sine of x times y squared. Okay? So there are three steps for finding a high order partial derivative, and actually let's just start with partial derivatives. The three steps for high order partial derivatives, I'll just call that HOPD, HOPD, meaning high order partial derivatives. That's what I'll be calling it. I want to write it all out. And step number one is to find partial of f with respect to x. And what that curly D means, I'm talking about partial derivatives, which is our main topic here. Alright? And I'll discuss what these mean later on in the video, but let's just finish writing all of them out for now. Step number two is to find df over dy, partial f with respect to y, and let me just change my color real here. And then our third step, multiply these partial derivatives together as many times as needed. Okay? And the third step I'll explain by drawing a diagram at the end of the video, but so far here are our main three steps. Yes, there are more, and I will discuss why that is later. But here are our three main steps. So now let's work through our problem. Okay, so actually what I will do is I'll copy these three steps just in case we need them later in the video. And our problem is going to be cut down here just a bit, but that's okay. Okay, there's our problem that's cut out a bit. And let me just erase these real quick. Okay, there we go. Let me set my brush. Okay, so here's our problem, right? And now let's work through it. Our first step was to find partial of f with respect to x. So what we need to do is find partial of f with respect to x equals, and what this is the derivative of this problem right over here, which is, let me just write it down again. It's our derivative of our problem, but since we're talking about partials, we always, since this is respect to x, right? We always treat this any y in the equation as a constant. So here, let me show you. This is a constant right here. We treat this as a constant, and we treat this as a variable. So now let's solve this. Let me switch my color. And this equals, right? So since we're treating x as a variable now, let's just find the derivative of the sine of x. And derivative of sine of x is cos of x. Cos of x times y squared. We don't find the derivative of that because that's just a constant. So that's what we get. And now our next step is to find the partial of f with respect to y. This equals d over dy this time of sine of x times y squared. And now, since we have this y at the bottom here, this y right here, we treat this as the variable. So this is the variable I'll just do b. symbolize that, and this is a constant. So now this equals, well, what's the derivative of y squared since that's a variable? That'd be 2y times sine of x because that's a constant. Alright, so now we have the partial of f with respect to y and the partial of f with respect to x. Now what if I told you I wanted to find partial squared of f over dx dy? This is where we get into high order partial derivatives. Okay? So now you can think, take a moment, pause the video and think, how from these two equations I have here, how can I get this? Okay, did you unpause the video? Well, the way we can do that is, well, let's think. What happens if we multiply this by d? We get d times d squared of f, right? Simple algebra. Over dx, right? We have a dx in this equation here. So what if we multiply it by dy? What? That's exactly what we have over here. We're finding the derivative of this. And watch, even if hopefully you know how to multiply fractions, but d times df, d squared times f, what we have here in the numerator, and dy times dx or dx times dy, what we have here in the denominator. But let's say I didn't want to do that. Let's say I wanted to find it out using this equation. Well, we still know that df times d equals dy, so we can put that d in the numerator over there. And dy, well, we have a dy here, so how about we just multiply it by dx? Same thing, we're trying the derivative of both of them, but a partial derivative, obviously. So now, let me change my color once again. Got it, okay. So now, let's just solve them. What's the derivative of this? Well, since we still have that y, we're treating y as the constant, so, sorry, y as the variable. So y squared will become 2y, because that's the derivative of any variable squared, using the power rule, times this cos of x. And I'll put y in front. Sorry, like a y variable in front for both of them, just to show you something. And now let's find this one, treating x as a constant. Well, cos of x, right? So I'm just going to put that right here, because I want to put y's first, times 2y, right? We have two exact expressions. That shows you that these two expressions, right? Sorry. Oh, let me just redo that. That these two expressions, this one and this one, are the exact same. Okay? And so we have, so both of these are equal. So this is equal to, and I'm just going to call this, so I always call df over dx, the partial of f with respect to x, f subscript x, and partial f with respect to y, f subscript y. So for this, I would just call it f subscript xy. Okay? So both of these are equal to f subscript xy, or in this case, f subscript yx, even though they're same thing. Xy, yx, same thing. So now I'm gonna draw. Actually, I'm gonna explain all the steps. Right? We found df over dx, df over dy. Sorry. And I always like finding both of them, even though in some cases you only have to find one, such as in this problem we did over here, where you only had to find one in order to find one of these, because both of these are the exact same. But in some cases, right, you might have to find df the whole squared over dx dy, which is what we would get if we multiply these two together. So in that case, you would have to find both of them. So I always consider it a good rule of thumb to find both partial of f with respect to x and partial of f with respect to y, right? And you can always find the derivative as many times as you want, right? So that's what our third rule meant, which was you can multiply these two as many times together as you want and find the derivative of them as many times as you want. And I already just explained our first two steps, right? Now, I'm going to show you a diagram that really helpfully explains our third step, okay? first. I'll be cutting off our first expression even more. Dang it. Let's see, so actually, you know what, I'll just erase all of this. I don't think you guys need a title anymore. You already kind of got, dang it. Okay. Okay, you know what? I'm just gonna do this real quick. Sorry it's taking so much time. And let me just delete all of this, and then we'll be good to go. I'll show you what my diagram is. Okay? So now let's go through it. So we started with our first which is basically our problem. F of xy equals sine of x times y squared, right? So now we went two directions from there. Our first direction, we found partial f with respect to y. And in our second direction, we found partial of f with respect to x, right? And we took another step from both of those, right? We found d squared f from here, this high order one from here, okay? And we found this one. We found it both ways, right? Found it both ways. And in this one, we did this using d over dx, and in this way, we did it using d over dy. Okay? So now, what I'm trying to show you is that, let me write this. I'm trying to show you that the third step is infinite. It can go on infinite ways. Infinity ways. Alright? We could do another derivative from here. We could do another derivative again from here. Right? We could multiply this by df over dy. We could do this times df over dx, and the same for both sides. There are infinite directions you can go to in order to find a high order partial derivative, or hot d, like I like to call it. So our answers for finding the high order partial, which was partial squared of f over dx dy, was ultimately 2y times cos of x, which we could have gotten going either way. Alright, so that just helps explain how there are infinite, and I can't stop stressing this enough, emphasizing this enough. There are infinite ways for step number 3. Alright. Well, anyway, I hope you guys had some fun learning this. Partial derivatives and high order partial derivatives are very, very important as you go on to learn gradients and etc. in your multivariable calculus class. Hope you had fun, and I'll see you next video.